Thank you very much, Professor Chiware, distinguished guests, colleagues. I will bring you greetings from the Department of Mathematics and Physics at CPUT. I could also bring you greetings from the Faculty of Applied Sciences, but I might be exaggerating my own importance if I do that. If I'd known I was presenting today, I probably would have shaved, but be that as it may. Today, it's going to be a fairly informal presentation. I'm not really presenting research as such, but reflections from, this is my 10th academic year as a WIL coordinator in mathematical sciences at CPUT. So I'm gonna kind of be presenting some reflections and thoughts around our theme of research and information in the literacy in the workplace. You'll notice that I've deviated slightly in my title on the slide from what's in the program because I deleted the research part. I decided to focus only on information literacy, although, of course, they are closely related. So I think when I say that I'm going to be reflecting on my own experiences, it's probably a combination of what we are doing and have done, and probably what we ought to be doing, but maybe aren't there yet. So it's not as if I'm here to tell you that I've been doing this for 10 years and therefore I know everything. We figured it all out, not by a long shot. But after what I'm going to be covering is after first talking about our context a little bit to give you a background. I'm going to speak to three critical, in my opinion, information literacy skills that I would classify as information literacy skills. I hope you'll agree with me on that, or otherwise correct me, that I think are particularly important to our graduates in mathematical sciences, but I suspect that they are also highly relevant in other fields as well. So as I said, I've been the WIL coordinator for mathematical sciences for the last 10 years. Well, it wasn't always called mathematical sciences. Originally, we offered a national diploma in mathematical technology, which became known as Math Tech. And then we changed the name with the recurriculation that took place around 2017. We then introduced the diploma in mathematical sciences. And as of 2020, we also introduced a higher qualification, the advanced diploma in mathematical sciences. And we also now have a postgraduate diploma in the pipeline that we hope to launch in 2024. So if I could sum up the mathematical sciences programs in one little picture, the core of what we are teaching is mathematics and statistics, but also increasingly data science. I believe Professor Chiware will be happy to hear that, as he mentioned that he's passionate about it. But we also teach some what we would refer to as domain knowledge, because mathematics and statistics is an applied discipline, or you have the pure mathematicians, but you generally only find them in academia. So if you want to apply your maths and your stats in the real world, you need to have some knowledge of that real world that you want to apply it in. So for that reason, we offer electives in things like physical sciences, biosciences, ecology, and then on the other side, we have economics and finance. So we actually divide the program into two streams. The applied science stream, which does the science electives, and the business stream, which does your finance and economics electives. So I think we could probably describe our program as a lead up to WIL. Like, I think one could argue that the whole first 2.5 years is kind of like work preparedness ahead of WIL, and then WIL is like the icing on the cake. So in the first year, the students are doing communication skills and computer skills as foundation subjects, but on paper, at least, the rest of the first 2 years is mostly your theoretical and technical subjects of mathematics, statistics, computer programming, etc. There is a bit of an issue there, which we've identified, which is relevant to information literacy and academic literacy, because in first year, first semester, the student learns communication skills. There's an academic literacy component. They go to the library. They learn how to reference. They learn how to prepare a PowerPoint presentation. They learn how to do academic writing. And then they don't really use it much until they get to third year, because you don't have to do a lot of academic writing in statistics class or in mathematics class. You have to solve equations and analyze data. So we are trying to address that by incorporating more assessments in the first 2 years that require the student to use more information literacy skills. But when they get to third year, they do a subject in the first semester called Introduction to Projects, which includes components of work preparedness and research methodology, but also require the student to do an academic project, sort of like a mini dissertation of sorts. And then in second semester, they do WIL. And then in the advanced diploma, it's a 1-year course. The first semester, it's all the back to maths and stats, theoretical and technical. Second semester, more of that, and then they do a WIL project module, relatively small, 12 credits. And I'll talk more about those. So we use project-based learning modality of WIL throughout our 2 programs, and that can be distinguished from, your workplace-based learning modality, for example, where, in some disciplines, WIL is all about getting almost like putting in time, like if you train as a pilot, it's all about the number of hours you got in the cockpit, right? That's how you measure that you are prepared for the job of being a pilot. It doesn't really work that way in mathematical sciences. You don't clock hours. It's about gaining experience of problem solving. And that we feel is best done through a project-based learning approach. Now, it can, like in our third year diploma, WIL, it often does follow kind of like an internship model where the student is based full-time at a company. So they are still getting, in many cases, that workplace experience and exposure to the professional context. However, that's sort of like a bonus. It's not the main event. So we would always, because I think sometimes you can get a difficulty in a workplace-based WIL where, the student is being asked to do photocopies or being given tasks and instructions that are not really anything related to the learning outcomes of their academic program. So, in order, not that we've had a major problem with that, but in order to avoid it, we make sure that the WIL partner company knows that the student is expected to do a project and they have to present their project and write a report on their project. And that's their main assessment for WIL, where most of their mark is coming from. So that the company, whatever other tasks and duties and responsibilities they give to the student, they understand that there is this, you could say the student must have their baby. They have to have something that is uniquely theirs, that is kind of like a self-contained project that they can complete in the space of a semester. And it's all about the problem-solving skills that they are going to get out of that project. The advanced diploma WIL, as I mentioned, it's less credits, and it's 1 out of 5 subjects that the student is doing at the time. So they're spending less time on it. It's not a full-time, it cannot be a full-time internship model. but we use a consultancy model where basically we encourage the student to see the partner company as a client, and it's like you're consulting for this company. They're giving you a task, they're giving you a project, maybe it's a data set, and they want you to gain insights and solve a real world business problem from that data set. So again, it's going to be assessed primarily through an oral presentation and a report that the student writes. And so I think it's already obvious that information literacy and academic literacy are going to be in the foreground of our WIL, because there's academic writing involved, there's oral dissemination of findings involved. Just to give you a flavor of some of the types of projects that our students have done in the past for their WIL, this is just a very small subset. I could give other examples, but and I've generally opted not to name the companies involved, but the first one is analysis of production downtime patterns in a manufacturing process. It's actually a beverage manufacturing process. So, when you're in manufacturing and in production, you don't want your process to stop, because that means you're not producing anything and you're not making money. So when the production line comes to a stop, there's data that's generated, and then you must go and analyze that data and figure out what are the patterns and trends in the downtime. Is a particular shift having more downtime than another? Is it a particular time of day? Is it a particular product that's leading to more outages on the production line? Then we have optimization of the size curve in clothing retail. So, any clothing retail chain that you might think of that has different stores in different areas, you may not be aware of this, but they have what they call a size profile of the customers who tend to frequent that store. So depending where the store is located, they might tend to get larger size customers or smaller size customers who shop there. So they have a profile in mind, and therefore they know what kind of size distribution do they need to stock in that store. Because if the inventory that they're stocking doesn't match the customers who are coming in, then they're going to have a problem, right? So it's about optimizing that. Another one is with a financial services provider that does retail store accounts, your retail store credit card, comparison of debt repayment patterns on retail accounts between debit order and non-debit order customers. So you can probably imagine that debit order customers tend to be a bit more reliable with their repayments than non-debit order because it's automatic. But how much of a difference does it make? Like, should the company really be incentivizing people to sign up for debit orders? Is it going to make a massive difference? Then we also have some government partners where you would have things like modeling of human migration between South African provinces. And jumping down to the last one, visualizations of crime rates by SAPS precinct. And our students have used maps to do that. So you can look at a map of the Western Cape, and every precinct will be a little shape on the map, and then the color will be red or yellow, or depending on how high a particular crime rate is in that precinct. So it's a nice visualization because you get a lot of information from one picture about what is happening in the province. And then going back up to the last two above that, forecasting hourly call volumes at a call center. South Africa is quite a hub for international call centers that serve international community. And it's very important to be able to forecast the call volumes, because that depends how many agents you need to have on the floor at a given time. So you want to optimize your resources. You don't want to have a whole bunch of agents sitting there that are doing nothing. On the other hand, you don't want to have too few agents where people calling in have to wait for 30 minutes on the line before they get to speak to an agent. And then customer segmentation for a mobile telecoms provider. So many retailers and businesses increasingly want to use algorithms that will segment their customers into different boxes, if you like. So you will have, if you look at a mobile telecommunications provider, you'll have your prepaid customers, you have your contract customers, but then also within your prepaid customers, maybe you'll have people that are topping up their data like every 2 days, and you'll get those that only buy airtime like once every 2 months, and the rest of the time are sending please call me's to their friends and relatives. So the company wants to segment their customers so that they know how to target them with marketing. So that's just an example to give you a sense, hopefully a context of the kinds of problems that our students tend to be working on. So I think the aim of our work integrated learning program in mathematical sciences is to deliver a win-win situation. It should be a win for our student, but it should also be a win for the company, because that will keep the company coming back. And maybe it might lead to the company employing the student after they graduate. So yes, it should be a rich real-world problem-solving experience, but it should also be a value-added solution to the external partner. When I'm trying to recruit WIL partners, I always tell them that I'm not asking you to do us a favor. We want you to see this as something that is in your interest, with your profit motive in mind. If it's a private company, we want you to see this as a smart business decision to take on a WIL student, because they are going to add value. And like the one WIL company partner told me, the way they look at it is they're getting a look at a potential employee without having to commit much to them, because it's a 6-month thing, and they can easily shake their hand and say goodbye at the end, and there's no expectation that comes with something further. But if they are really impressed with the student, then they have the option to offer them something further. Okay, that's the background. Now we get into 3 critical information literacy skills that I believe are critical to the success of students doing these types of projects, and then more importantly, after doing such a project, being employable, being able to succeed in the workplace. So I don't necessarily have the right technical terms. You will probably have better terminology to use for some of the skills that I'm going to describe as information literacy experts. So I just kind of picked a name that sounded intuitive to me in some cases. But the 3 skills that I'm going to talk about are what I would call choosing the tool for the job. And then the second one is self-directed learning, which I think is a bit more of a technical term. And the third one is communicating technical information to a non-technical audience. So the first one is choosing the tool for the job. So, if we think of the metaphor of a tool for DIY, maybe plumbing or something on your house, just because you have a full toolbox, it doesn't mean that you're equipped to do the job, right? Now, there are cases like a while back, I called a plumber for the blocked drain, and sure enough, he came with this. I had my little plunger, and then he came with like what he called a super plunger. So he definitely had the tool for the job that I didn't have. So sometimes, and it worked as well. So sometimes you just don't have the tool for the job, and you need somebody that brings that tool. But in other cases, you might call a handyman, or should I say handy person, to be gender neutral. That person might come, and you might notice that his toolbox or her toolbox is the same as mine. Like the tools that I have in my toolbox are no different than what's in that toolbox. And then you start to feel embarrassed, like, so why did I have to pay somebody to do this job? Because I have the tools. But the problem is you don't know which tool to use in which way to get the job done. That's the skill that handy person brings that you don't have, and that's why you have to pay them the big bucks. So in the maths and stats context, you know, the tools that we're talking about for the most part are methods and models. So I usually say to my students at the end of second year, you know, they've had 4 semesters of statistics and they've learned a lot of different methods. They've learned correlation analysis, they've learned regression analysis, ANOVA, and all these different methods. But I say, but the question is, do you know which method to use in a given situation? Because if you don't, you're going to be like that handyman standing there with a full box of tools, but doesn't know which tool to use for the job. And then the pipe is exploding and water is going everywhere. So you don't want to be that person. So you have to be able to choose the right tool for the job. And that, to me, that's an information literacy challenge. It's not, and it's not discipline specific. I imagine the same thing is true in any discipline. There will be specialized, what you could call as the tools of the trade in your discipline, but just having a laundry list of those methods. And if someone says to you, take this method and apply it to this, you could do it, but that's not enough, because you have to be the one to know this is the right tool to use in this situation. And that to me is critical and often one of the more difficult things for students to learn. So I think sometimes our syllabi focus too much on putting more tools in the toolbox. Let's teach another method. Okay, now let's teach another method and another method. Now you're overwhelming the student with 20 different methods that they can choose from, but you didn't teach them how to decide which method is right for a certain situation, and that becomes a problem. So I think project and problem-based WIL experience is crucial here, because that's the situation after learning all of the methods where the student has to now apply, choose, given the real world problem they are confronted with, they now have to go to their list of 20 methods and decide this one will be suitable here and this one won't be. And it's a trial and error thing, because, you know, there's a saying that says, when you're holding a hammer, everything starts to look like a nail, right? So, and I've seen that with our students, because there's a statistics subject that is taught by blended learning the same time that the students are doing WIL. And for some reason, the students always want to use the methods from that subject in their WIL, even if they're not relevant, because it's fresh in their mind. So they're holding the hammer and now they're looking for a nail. But what they have in front of them is not a nail. It's maybe a screw, and you cannot use a hammer on a screw. So choosing the tool for the job is critical. Now I want to talk about self-directed learning. That's the second of the 3 critical skills. And I think we've heard a lot today about lifelong learning, and I think it's closely related to this concept. So I'll give you a formal definition as far back as 1975 from Knowles, but I don't think it's necessarily changed too much. I could be wrong. But Knowles says that self-directed learning describes a process in which individuals take the initiative, with or without the help of others, in diagnosing their learning needs, formulating learning goals, identifying resources for learning, choosing and implementing appropriate learning strategies, and evaluating learning outcomes. Maybe what has changed the most is that there are so much more resources available for self-directed learning today than there were in 1975 with the internet and everything else. So I would maybe try to phrase this in a one-liner as saying that a university education does not turn on the question of what to learn, but how to learn. So it's not just about the content. It can't be so content heavy, the education that we provide to our students. It's not about, again, a laundry list of things that you must know, because the world is changing so rapidly. We cannot possibly teach the students all the content, all the knowledge and things that they are going to need to know in their career, which is going to continue for the next few decades. So instead, there is some content we have to teach them, but alongside that, we have to equip them with the skills to add their own content after they graduate, to continue learning themselves. So what does that entail? I think information literacy is key to self-directed learning. Google is your friend is a phrase I find myself using a lot when trying to encourage students in the direction of self-directed learning. But part of, I think, an underrated skill is actually knowing how to Google something effectively, you know, putting a phrase in quotation marks as opposed to not putting it in quotation marks can get you a very different result. And do our students know that? Otherwise, they may be scrolling through page after page of Google results, not finding the answer that they want. And also, self-directed learning requires one to know what one doesn't know. If you don't know that you don't know it, you're not going to go looking for the information. So you have to realize that there's a tool missing from my toolbox, that none of the tools that are in my toolbox can actually do this job. So I need to go out and find that other tool. Now, in our discipline, there's a lot of writing of code that happens, you know, for statistical analysis and mathematical modeling. There's a lot of writing of code in different programming languages like Python, R, etc. So debugging becomes a very important skill, because if you have ever written any code, you will know that it never works the first time. You always get an error. And those that designed programming languages seem to have a way of making the error messages that you get to be very cryptic. So you actually have no idea what's going wrong in your code when you read that message, like illegal function call and so on. You just say, what does that mean? So what my students tend to do is send me a screenshot of their, you know, their console where they're writing their code with the error message and say, sir, why isn't my code running? And that's not I can give them the answer in some cases, but that's a band-aid solution, because I'm not going to be there to receive screenshots throughout their career. So they have to learn, where do I find the answer to debugging my code? And there are some wonderful resources that are out there. Online forums. The two that I use heavily myself are called Stack Exchange and Stack Overflow. They're part of the same website. I think the name stackoverflow.com, I think the name Stack Overflow comes from one of those cryptic error messages that programmers used to get, where it says Stack Overflow and they're like, what does that mean? I don't know how to fix that. So it's a place when you get that Stack Overflow error message, you can ask your question. But the interesting thing is, I've probably gone on Stack Overflow, like, I want to guess more than 1,000 times over the last couple of years, like as I've been doing my own PhD research, or just learning something new myself to use in my teaching. I'm always going on there, but I very rarely actually have to ask a question, because you can ask a question and hopefully someone will answer it. But the thing is, I start off by Googling, and it will usually take me to a page on Stack Overflow where somebody has already asked my question and gotten the answer. So 99% of the time, the question that I want an answer to has already been answered, because somebody else had the exact same problem and the answer is sitting there on the internet. You just have to know how to look for it, and you have to know not only how to look for it, but you have to know that it's possible to look for it. Because why are my students always sending me screenshots and not going on Stack Overflow? Because they probably don't know that it exists, and they don't know that they can get the answer so easily from the internet. So these are some of the resources that are at our fingertips if we only have the information literacy to seek out those resources. So I think, coming back to the issue of will, I think that a good will experience, we need to throw our students in the deep end a little bit, because there's a balance. We don't want to throw them in the deep end too much, because we want the student to feel gratified when they get into the will environment. They should discover that their knowledge and skills that they've been learning in their course are actually useful in the real world. That will be gratifying because they will feel like, okay, I haven't been wasting my time for the last 2 years. And I think that's especially maybe relevant in mathematical sciences because sometimes the students are sitting solving all these equations and you're asking themselves, when am I ever going to use this? So when you get out into the workplace and you start to realize that, okay, what I've been learning, it actually has a place in the real world. But at the same time, I think that we also want our students to feel challenged because they need to discover that not everything that I'm going to need in the workplace, I've already learned. In other words, there are things that I need to know to do this job, to do this WIL, that I don't know, that I didn't learn in my subject. And it's not because my lecturers were incompetent or the curriculum is badly designed. It's just because there are too many things that one needs to know that it can't possibly be fit into a curriculum. It's too diverse in mathematical sciences and I'm sure in other disciplines. So they should be challenged and realize through their WIL experience that they needed to pick up additional knowledge and skills on the fly. It might be a new software that they had never used before that employer is using heavily, and now they have to learn it on the fly. Or it might be another statistical method that was not covered in the course, but happens to be the right tool for the problem that they're working on. Whatever the case is, they should be challenged and realize that I am going to have to develop this self-directed learning way of living in my life if I'm going to be successful in my career. That brings me to the third and last. How is my time? Am I still okay? The third and last skill that I want to speak about, I wish I could have thought of a punchier way to put it than this very wordy description, but communicating technical information to a non-technical audience. I think it's a challenge in any discipline, and maths and stats are certainly no exception. Maybe maths and stats are particularly susceptible to this because we often hear of phobias in maths and stats. When you even mention that you're a statistician, then people don't want to talk to you, or they say, no, you're a different kind of person. So there is this phobia that some people have, and I feel that it's maybe down to the way that it was taught to them, even in primary school. That phobia already starts to develop. But it is there, and so you might be communicating stats to somebody that has a phobia of stats. So you have your work cut out for you. And, you know, sitting in on students' final WIL presentations where they present their projects back to the company, you often hear questions from the company, which is often a non-statistician, a non-mathematician, maybe a manager. Can you explain this graph for me in layman's terms? How can we as a business use this information? What is the take-home message here? So when you hear the company asking that question, you realize that the student still has somewhere to go in terms of communicating the technical information to a non-technical audience, because the core message of what needed to get across to the company hasn't quite gotten across. But it's a learning experience. Once they hear that question, they realize that, okay, it's not enough just to present some fancy graphs and numbers. It's not about just impressing them and blowing them away with how complicated my models are. It's actually about solving a problem at the end of the day. I often, there's a quotation attributed to Albert Einstein, which, I think a lot of things are attributed to Albert Einstein, probably 90% of which he never said, but whether he said it or not, it was something along the lines of, any fool can make something sound complicated, but a genius will take something complicated and make it sound simple. So I think sometimes we have, and our students have this mentality that if I can present something very complicated to the company, they're going to be wowed by how smart I am, because they've never heard of these models and I'm using all these fancy terms. But the company is actually not impressed with that. They want, at the end of the day, to know, how does this solve our problem? Did you actually solve our problem? So we need our students to learn not to try to wow the audience with jargon and fancy methods. Another issue we see is that students spend too much time on minutiae. So a classic example of this is that the students have tables of stats and they're reading off every number up to the 5th decimal place. Now, probably only the first decimal place is actually of any real world importance. So why are you reading it up to the 5th decimal place? It's because you focused on the minutiae, on the finer details, rather than on the big picture of what really matters to the client. And then there's also sometimes the case of information overload, just presenting too much and not getting to the point. So the opposite, what do students need to learn to do when communicating technical information to a non-technical audience? They need to learn how to distill 1 or 2 key points from a graph or model output and not feel that they have to explain every last detail of the model or graph. Focus on what really matters to the audience. Leave unnecessary technical details out of the slides. You don't necessarily have to explain equations and things that are not relevant to that audience. If you're discussing it with your supervisor, maybe, but in a workplace context, it may not be necessary. And make sure that you translate your findings and recommendations into the language and context of the audience to answer that question of, what does this mean for us? How can we as a business take this information that you've presented and make a decision for our business that's going to increase our profit, or reduce our costs, or whatever the case is, improve our productivity. So, in conclusion, I think that the ideal WIL experience, from my perspective, should offer the student a golden opportunity to hone these 3 key information literacy skills. I'm not saying they're the only ones by any means, but there are 3 that I've picked up on in the last decade as being of particular importance to our students succeeding in the workplace context. And I do want to emphasize the word hone, because it implies a long process. It's not something that they can master in the space of the semester that they spend doing WIL. That's why we have to introduce it from first year and find ways to hit on these skills in all of the subjects that they do leading up to WIL. And then, of course, it's a process that will continue after they finish their WIL and hopefully take forward into their careers. Thank you for your attention.